Let's consider this limit. So here we have exponential, we have, so first things to do is to replace x by 0 and y to 0 and see what happens. So x0, y0, so we end up with exponential 0 minus 1 over 0. Exponential 0 بكم شباب؟ 1. So it's 0 over 0, so indeterminate form. Okay, so we cannot calculate directly the limit. So he proposed, give me a hint, use polar coordinates. So again, we can say that x is r cosine theta, y is r sine theta. When xy goes to 0, tends to 0, this means that r tends to 0 plus. And there is also an important feature of polar coordinates. We used it in previous exercise. We calculate it, but we can use it directly. So here you can see that x square plus y square, this can be replaced by r square. Okay, so if this is r, and in the right triangle it's root x square plus y square. Okay, so this is the relation if we want to express r in terms of x and y. Okay, so this is also for interest. So for example, here if I rewrite my limit in polar coordinates, so in the denominator we have x squared plus y squared. We can directly replace this with r squared. Okay, even in the numerator, this quantity is nothing else than if we make minus as a common factor, x squared plus y squared. So we can also rewrite it as exponential minus r squared minus 1. Okay, so this limit is rewritten in polar coordinates in this way. Okay, so if we replace r by 0, we'll get exponential 0, 1 minus 1 is 0 over 0, still in the indeterminate form. Of course, we didn't simplify yet. So we have here two options. The first option is to simplify. Do we have any possible simplification here, any factoring? So no, it seems difficult. This is exponential minus 1, no common factor. R2 already factored in the denominator. So here we can use L'Hospital rule, okay, to calculate the limit. شفناها in the first session. مين يذكرني بها؟ I know this limit is the same as the derivative of the numerator over the derivative of the denominator, and here the derivative is with respect to r. So in the denominator, the derivative is easy. What is the derivative of r square? If we derive with respect to r, how to derive r square to r. And what is the derivative of this quantity? So the derivative of exponential u of x, we said that it's the derivative of u times exponential u. Okay, so it's the derivative of minus r square اللي هي minus 2r times exponential minus r2, and the derivative of the constant is, what is the derivative of minus 1?
0.
Is 0. So this is gone. So using this rule, we end up with this limit, and here we see that we can simplify. So this is good news. We can simplify, so mean that we are moving forward to the final answer. So r and r goes 2 and 2. So it's the limit when r goes to 0 plus of minus exponential minus r2. If I replace r by 0, I end up by minus exponential 0, which is minus 1.